Good evening, sir.
Good evening, ma'am.
Sir, you can start, sir.
Okay, ma'am. Okay. Good evening. So last week I gave you a test containing 15 multiple choice questions. So I hope you might have attended the test. So now I'm going to discuss the solutions for the questions, okay, on which I gave you test. After that, we will be continuing our discussion on AC circuits, okay. So let me open the PDF file now. Are you able to see my screen?
Yes, sir.
Okay. So see the first question. This is the first question which I gave you. If the RMS value of AC is IRMS, so then peak to peak value is, okay, if the RMS value of AC is IRMS, then peak to peak value is. They have given you 4 options. We need to choose the right one. So first of all, we need to understand what is the meaning of peak to peak value. So see the graph, okay. So here, this is the positive half cycle, and in this, I naught is the amplitude, okay. I naught is the amplitude of the current, and this is for positive half cycle. The peak to peak value is actually from here to here, okay. So from the graph itself, we can understand that the peak to peak value is actually twice the amplitude, okay. Peak to peak means from here, this point, this is one peak, and the negative peak also you need to take. So the values corresponding to peak means from here to here, you need to find out the current value. So that is peak to peak value, and that is twice the amplitude. So the peak to peak value is nothing but twice the amplitude. So that means amplitude I naught is equal to peak value divided by 2. So this thing you need to understand very well. And of course, we have the formula IRMS is equal to I naught by root 2. That's the formula which we have already discussed. So IRMS equal to I naught by root 2. And here I naught is related with peak to peak as I peak P divided by 2. That is half of the peak value. So here, instead of I naught, I need to substitute this IPPP, that is peak to peak value. So IPP divided by 2 into root 2. That's the IRMS value. And we need to know the peak to peak value, that is IRMS into 2 root 2. So 2 root 2 IRMS, and that is option C. That is given in option C. Okay. So this is how you need to approach this problem. And the second question is, if the instantaneous value of current is I equal to 100 sin 314 t ampere, then the average of current in ampere for half cycle is, okay. We have been given 4 options. So here you see the average value of current. For that we have this equation, standard equation, I average equal to 2 by pi into I naught, where I naught is the amplitude. So given equation is I equal to 100 sin 314 t. So when you compare this with the standard wave equation form, that is I equal to I naught sin omega t. Okay, when you compare this given data with the standard form, you will be getting I naught equal to 100. So using this, you need to find out the average value of current. I average equal to 2 by pi into I naught. I naught is 100. Okay. 2 by pi into 100. So 2 by 3.4 into 100. So that will be 63.7. Okay. 63.7, that is option C. Okay. Just the simple formula, I average equal to 2 by 5 into 100. Using that formula, you can always solve this. And the third question is, the equation of current in an AC circuit is I equal to 4 sine 100 pi t plus pi by 6 ampere. The current at the beginning, that is t equal to 0, will be. Okay, they have given you the equation for current. And from that, you need to find out the current at the beginning, that is t equal to 0. It is also a simple problem. So in the question, substitute t equal to 0. Okay, substitute t equal to 0 and then you can find the solution. So here at t equal to 0. So this is the equation given. Substitute t equal to 0. Then you will be having 4 sine 100 pi into 0 plus pi by 6. So this term will vanish. Instead, you will be getting 4 sine pi by 6. So pi by 6 means actually 30. Okay, sine 30 degree, it is 1 by 2. So 4 into 1 by 2, that will be 2 ampere. So that is option B. Okay. Then question number 4. RMS value of AC I equal to I1 cos omega t plus I2 sin omega t will be. So this is the value of current. I equal to I1 cos omega t plus I2 sin omega t is the current actually. We have to find out the RMS value of this current. Okay. How we can do that? RMS value means, by definition, it is root mean square value. Root mean square means, first of all, you need to take the square and then you need to find the average. Okay. After that, you need to take the square root. So here you see, I have taken the square of this thing. Okay. And then what I have to do? I have to take the average. Average is represented by taking the bar on it. And then I have to take the square root. This will give me IRMS. Okay. By the definition itself, it is root mean square value. Root mean square means, here I have taken the square. You see, this is the value of current given. Taking the square, I will be getting, I have to expand this by a plus b whole square formula. So I1 squared cos squared omega t plus I2 squared sin squared omega t plus 2I1 I2 sin omega t cos omega t. This is the square. And then I need to take the mean. Mean means arithmetic mean or the average. Then I have to take the square root. So if I want to take mean or average for this terms, okay, what I have to do is, I have to take average only for these variables, cos squared omega t, sin squared omega t, and this sin omega t, cos omega t. Okay, have to take the average only for these variables. All the other terms are constants, so there is no question of doing anything when you talk about mean or average. So here I have put bar over the cos squared omega t. Okay, this term I have to take the average, that is cos squared omega t, and this is sin squared omega t, and then I have to take the bar, and then sin omega t, cos omega t. Over that we will be putting bar, okay, to denote the arithmetic mean. Now you have to find out the average value for these terms, cos squared omega t, sin squared omega t, and all. And we know very well average value of this sin omega t and cos omega t will be 0. Okay. So that thing we have discussed already. So these terms will vanish. Okay. Because average value of sin omega t and cos omega t both are 0. So this term will vanish. And what is the average value of cos squared omega t? That will be 1 by 2. Similarly, for sin squared omega t, the average value is 1 by 2. You have to substitute 1 by 2 and 1 by 2. Okay. So here you can see 1 by 2. And here also it is 1 by 2. That means I1 squared plus I2 squared whole divided by 2. And then you need to take the square root. And you can take 1 by root 2 as common outside. And the square root of I1 squared plus I2 squared means power whole power 1 by 2. Okay, that is I1 plus I2 whole power 1 by 2. That is option C. Okay, that is option C in the question. They have given option C. Okay, that's the option. Right option here. And question number 5. In a certain circuit, E equal to 200 cos 314t and I equal to sin 314t plus pi by 4. Their vector representation is. They have given you 4 diagrams, 4 vector diagrams, and you need to find out the correct diagram showing the relation between this EM of E and the current I. Okay, and the angle between them. So you need to choose the correct vector representation to represent the EMF and current. Okay. So if you want to do that, okay, first thing you need to keep in mind is that the EMF is in cosine form. Okay, 200 cos 314t, and the current is in sine form. Sine 314t plus pi by 4. This is sinusoidal form, and this is cosine form. Okay, you have to convert this cosine form into sine form, or this sine form into cosine form. Okay, then only you will be able to get the correct vector representation. So the first thing is EMF, E equal to 200 cos 314t. I have to convert this into sinusoidal form. So what I have to do is I have to add this thing with pi by 2. Then it will become sine. Okay, so 200 sine pi by 2 plus 314t, and I equal to sine 314t plus pi by 4 is the given equation, and this equation E we have converted into sinusoidal form. So here, what is the value of phi E? Phi E means what is the phase value for this EMF? That is called phi suffix E. Phase corresponding to this EMF equation, that is represented by phi suffix E, and that is pi by 2 plus 314t. Okay, that is the phase, and phase for current is, as mentioned here, 314t plus pi by 4. Okay, pi E is pi by 2 plus 314t, pi I is 314t plus pi by 4, and you need to subtract pi E and pi I. Okay, subtracting pi I from pi E. So you have to minus 314t minus pi by 4. Pi by 2 minus pi by 4, that will be pi by 4. Okay, so that is option A. EMF will be leading. Okay, EMF will be leading. So here you see, EMF is leading the current. Okay, so that is pi by 4. Do you all understand the solutions for this problem, students? Do you have any doubt on this? As I keep on discussing the solutions, if you have any doubt on solutions for these 5 questions up to this point, students, any doubt? Okay, it seems you don't have any doubt. Then I will be discussing the 6th question, solution for the 6th question. So in an electrical circuit, the applied alternating EMF is given by E equal to 100 sin 314t volt, when current flowing I equal to sin 314t plus pi by 3. The impedance of the circuit is, okay, you need to find out the impedance. So how can you find out the value of impedance? Impedance is nothing but resistance. So Ohm's law you know very well. Okay, Ohm's law you know very well. So V equal to IR actually. So R equal to V by I. So here instead of resistance you are having impedance. Impedance is nothing but E by I. Okay, E by I. So actually E by I means that is amplitude. You need to take the amplitude of the voltage and the current. So for current, you don't have any term here. That means the amplitude is 1. For EMF, you have 100 here, so the amplitude is 100. So impedance is equal to E naught by I naught. That is the ratio of the amplitudes. That is given by 100 divided by 1. That is 100 ohm. So option B. Okay, option B is the right answer for this question. Then question number 7. The impedance of the given circuit will be. You see what are the elements present in the circuit. You have a resistor and you have the inductor coil. Okay, resistor and the inductor coil. You need to find out the impedance. How can you find out the impedance? You have the formula when you have in RL circuit. Okay, an inductor and resistance, when they are present, you have the impedance formula Z equal to root of R square plus XL square. So XL, I think they have given you straight away. Okay, 200 ohm. 200 is the XL. XL means inductive reactance. Okay, but I have reversed the orders here. Okay, but you don't bother about that. Here 200 ohm is actually XL. Okay, 200 ohm is XL. They have given you the XL straight away, so you can substitute it directly. 200 square plus R is nothing but 150. So square root of 200 square plus 150 square will give you 250 ohm. That is option D. Okay, option D is the right answer. Then question number 8. The impedance of the given circuit will be. Here you have RC circuit. You have a capacitor and you have a resistor. Okay, and you should observe carefully. Here you have a DC source. Okay, here you have a DC source, and they are asking you to find out the impedance for this arrangement. A resistor and capacitor. Okay, so you should not straight away go for the formula for impedance here. You should observe what is the source given here. It is a DC source. When it is a DC source and you see a capacitor here, you should remember that a capacitor offers infinite resistance to DC. That means this capacitor alone offers infinite resistance or impedance to DC here. Okay, a capacitor offers infinite resistance to DC. So here you see, here you have a DC source, means the capacitor actually offers infinite resistance. So option B is the right answer. Okay, infinite. It is the impedance. It doesn't matter what is the resistance offered by this resistor 150 ohm. The capacitor itself offers infinite resistance to DC. Then question number 9. If E naught equal to 200 volt, R equal to 25 ohm, L equal to 0.1 Henry, and C equal to 10 power minus 5 farad, and the frequency is variable, then the current at F equal to 0 and F equal to infinity will respectively be. You have been given EMF value, resistance value, inductance value, and capacitance value, and you need to find out the current at different frequencies. Okay, current at different frequencies, and it is a LCR circuit. You can see from the diagram RLC. Okay, and you need to find out the current value at the frequency F equal to 0 and frequency F equal to infinity. How can you find out the value of current? You need to use this formula. I naught equal to E by root of R squared plus XL minus XC the whole square. So instead of XL, you need to put 2 pi FL. So that you know very well. Instead of XL, you need to put 2 pi FL. And instead of XC, you need to put 2 pi FC. Okay. So root of R squared plus XL minus XC the whole square here. So instead of XL, you need to put 2 pi FL. Instead of XC, you need to put 1 by 2 pi FC. Okay. So this is the equation for finding out the current. In the question, they have asked you to find out the current at frequency 0 initially. So when you put 0 here, okay, this term will become 0. But here, frequency is in denominator. When you put 0 here, this will become infinity. Okay. So that means square root of R squared plus, here you will be getting infinity square. Okay, infinity square. So square root of R squared plus infinity squared, it will be again infinity. So in the denominator, you will be having infinity. So I naught equal to E naught by infinity. Anything divided by infinity will be 0. So for frequency f equal to 0, the current will be 0 ampere. And the second case is when your frequency is infinite. So here also you need to apply the same formula, this formula. I naught equal to E naught by this formula. So instead of frequency f, you need to substitute infinity here. So here you will be having 2 pi infinity L. That means this term will be infinity. And here when you put infinity in the denominator, this term will become 0 because anything divided by infinity will be 0. So here this term will become 0, but this term will be infinity. So infinity squared plus r squared, once again it is infinity. So E naught by infinity, that will be 0. So in both cases, your current is 0 ampere. Okay. So option D you can see 0 ampere and 0 ampere. Now let us move on to question number 10. RMS value of current in the circuit given will be. You see here you have a AC source and EMF factory has been given here. You need to find out the RMS value. How can you find out the RMS value? For that you need to find out the peak value of current initially. Okay. So here you see I equal to E by Z. Okay, I equal to E by Z. You have been given E in the question and Z you need to find out. Z is the impedance. So 10 ohm and 10 microfarad are here. Impedance you can find out. Square root of R squared plus 1 by omega C the whole square. Using this you can find out the impedance. Omega. Omega, how can you find out? Here you see E equal to 100 root 2 sine 10 power 4t. You compare this with the standard equation form, that is E equal to E naught sine omega t. Instead of omega, you are having 10 power 4. Okay. So that you should use here. When you need to apply for omega, you need to put 10 power 4 here. And C value. C is 10 microfarad. That is 10 into 10 power minus 6. After applying, you will be getting impedance value 10 root 2. And then I equal to E by Z. E you know very well and Z you know very well. After dividing this, you are getting I equal to 10 sine 10 power 4t. This means I naught is equal to 10. Okay. Once again, the standard way equation form, I equal to I naught sine omega t. When you compare this with this thing, your I naught will be 10. So I naught equal to 10. I RMS is equal to I naught by root 2. So 10 by root 2. When you simplify this, 10 will be 5 into 2 divided by root 2. So this 2 and this root 2 will be cancelled and you will be getting root 2 on the numerator. So I RMS equal to 5 root 2 ampere. That is option B. Then question number 11. The reading of ammeter in the circuit shown will be. They have given you a circuit. Okay. And you need to find out the reading of the ammeter. Ammeter reading means you need to find out the current value. Current, how can you find out? I equal to V by Z. V they have given you 110 volt. Okay. This is LCR circuit actually because you have inductor coil and you have resistance and you have capacitor of inductive of capacitive reactance value XC equal to 5 ohm. So this XC, XL and R you have and you need to find out the impedance value. So Z equal to root of R square plus XL minus XC the whole square. So instead of R 55 square plus XL minus XC the whole square means XL is 5 ohm and XC is also 5 ohm. That means both XL and XC will get cancelled each other. That means the circuit is at resonance now. So Z equal to root of R square. Root of R square is equal to root of 55 square. So that will be 55. So I equal to E by Z, that is 110 by 55. That will be 2 ampere. In question number 12, in an LCR circuit, the resonating frequency is 500 kilohertz. If the value of L is increased 2 times and the value of C is decreased 1 by 8 times, then the new resonating frequency in kilohertz will be. So they have given you an LCR circuit and the resonating frequency 500 kilohertz. Now they are changing the values of L and C. and they are asking us to find out the new resonating frequency. For that, you need to use the standard formula. F is equal to 1 by 2 pi root of LC. Okay, I think you know very well this formula. F equal to 1 by 2 pi root of LC. So the first case they have given you 500 kilohertz is the resonant frequency for L1 and C1. And in the second case, the inductor value is doubled and the capacitance value becomes 1 by 8 times. So instead of L1 and C1, you need to substitute L2 and C2. So instead of L2, that is 2L1, C2, that is C1 by 8. So when you cancel out this 2 and 8, you will be getting 4. So square root of 4 in the denominator, you will be getting 2. And that 2 will go to the numerator. Okay. So 2 by 2 pi root of L1 C1, that is 2 into F1. Okay, because F1 you know here 1 by 2 pi L1 C1. So instead of this term, you will be having 2 into 1 by 2 pi root of L1 C1. So that will be give 2 into F1, that is 2 into 500 kilohertz, that is 1000 kilohertz, option C. Okay. Then question number 13. Here, if you please observe carefully in the question, it was given as 0.5. Okay, option B. Option B is not 0.5. Option B is actually 0.2. You please make that correction. Okay. So after carrying out the correction, you can get the correct value. So in the question, option B is 0.2, which is the right answer here. But in the question paper which was given to you, it was 0.5. So please correct that mistake, rectify that mistake, and take option B as 0.2. Okay. So let us see what they have asked. In a resonating circuit, values of inductance and capacitance are 0.1 Henry and 200 microfarad respectively. For same resonating frequency, if the value of inductance is 100 Henry, then the necessary value of capacitance in microfarad will be. Okay. So resonating frequency, they have not given initially. Okay. What they are telling is, if you want to maintain the same resonating frequency, when the inductor value is made 100 Henry. Okay. Initially, the inductor value is 0.1 Henry and 200 microfarad capacitance you have, and you are having some resonating frequency. And now you need to maintain the same resonating frequency by changing the value of inductance and capacitance. So inductance value, how they are changing? They are changing it to 100 Henry. And what will be the necessary value of capacitance that should be put here? So FR equal to 1 by 2 pi root of L1 C1. So L1 is 0.1, C1 is 200 microfarad. You are putting it that, and then the same resonant frequency you need to maintain. That means FR is equal to 1 by 2 pi root of L2 C2. That is equal to 1 by 2 pi root of 100 into C. C value we need to find out. So both are same resonant frequencies. So you need to equate both these equations. When you equate both these equations, okay, you need to proceed like this. This 1 by 2 pi, 1 by 2 pi will be cancelled out. So you need to take square on both sides. That will be 1 by 100 into C. That is equal to 1 by 0.1 into 200 into 10 power minus 6. So C is equal to now 200 into 0.1 into 10 power minus 6 divided by 100. So when you simplify this term, you will be getting 0.2 microfarad. That is option B. Okay. And now question number 14. This is just a theory based question. In an AC circuit at resonance, okay, what will happen? If your impedance is equal to R, your impedance is equal to 1 omega L minus 1 by omega C. The voltage across L and C are in same phase. The phase difference of current in C relative to source voltage is pi. Actually, impedance value you can find out using this equation. Root of R square plus XL minus XC the whole square. So in the question they have mentioned it is a resonance condition. Okay, at resonance. So at resonance, your XL will be equal to XC. So that means this term will become 0. So impedance is equal to square root of R squared. That will be R. So in the question option A, it is impedance equal to R. So option A is the correct answer. Then question number 15. An AC circuit resonates at a frequency of 10 kilohertz. If its frequency is increased to 11 kilohertz, then its impedance will increase by 1.1 times. So they have given you four options. Okay. They have given an AC circuit at resonating frequency 10 kilohertz. And when the resonating frequency is increased to 11 kilohertz, then what will happen to the impedance? So for that, we will use the impedance formula. Impedance is equal to root of R square plus XL minus XC the whole square. So at resonance, you know very well XL equal to XC. So impedance will be root of R square, that will be R. So impedance depends only on R, okay, and not the resonating frequency. So impedance is independent of frequency. So even though if you change the resonating frequency to 11 kilohertz, your impedance will remain unchanged. So option B. Okay. And these are the solutions for the numerical problems which I have given you test last week. Do you all understand the solutions for these questions, students? Anyone have any doubt? Up to this point, anyone have any doubt?
No, sir.
Yes, other students, do you have any doubt? Okay, I hope you don't have any doubt. Okay. Okay. Now we shall move on to the next concept. Okay. So our next concept is we have discussed up to resonance. Now power in AC circuit. Okay. Power in AC circuit we are going to discuss this concept. Power in AC circuit. I will be sharing my whiteboard with you. The power in AC circuit we are going to discuss. So what is mean by power in general? Students, in general, what is mean by power?
It is amount of work done.
Very good, excellent. So that is the amount of work done. Okay. So the rate of work done is actually called power. The rate of work done. That means work done divided by time. Okay. The rate of work done or work done per second, you can call it that way also. In an electrical circuit. In AC circuit, that is called power. So what is the equation for power when you have potential difference and current? P equal to VI. Okay. That is power. So power means work done per second. And when you have power and you need to find out the work done, you need to multiply power with time. So when you multiply power with time, you will be getting VIT, work done equal to VIT or P into T. So what is the SI unit of power? Can anyone tell me? SI unit of power. What is the SI unit of power? Students, what is the SI unit of power?
Sir,
Yes.
what, sir?
Yes, WATT watt. Okay. So WATT watt is actually the SI unit of power. Okay. So SI unit of power is nothing but watt. And of course, in our households, we used to have motors, okay, for drawing water from underground. So that motors and their powers will be mentioned in HP, horsepower. So what is the equivalent of this 1 HP? 1 HP equal to 746 watt, okay? And this is the conversion which you need to understand. And in an AC circuit, how will you calculate the instantaneous power? Okay, that we will be discussing now. Instantaneous power. So instantaneous power means here also you will be having voltage and current. Instead of voltage, we call it EMF. Okay, if your EMF is E naught sine omega t plus phi, and your current is I equal to I naught sine omega t. Then what is the value of your instantaneous power? So that is represented as P instantaneous. Okay, P suffix instantaneous. That is equal to E into I. That will be I naught sine omega t multiplied by E naught sine omega t plus phi. Okay, this is how you need to find out the instantaneous power. And how to calculate the average power in an AC circuit. How will you calculate the average power? So average power means you can represent the average power using this symbol. So integral 0 to P of t dt whole divided by integral 0 to t dt. Okay, this is the expression for finding out the average power, and the instantaneous power you have here. Okay, so that is E naught I naught sin omega t multiplied by sin omega t plus phi. Of course, you have dt divided by, so you need to integrate 0 to t. In the denominator, when you integrate dt, okay, with respect to 0 to t, you will be getting time t. So after integration, the average power is given by this expression. Okay, so we are not going in depth into the derivation part. I am just writing out the final step for the average power. ERMS, IRMS into cos phi. Okay, ERMS into IRMS into cos phi, where phi is the angle between E and I. Okay, this is the expression for the average value of power in AC circuit. So these formulae are important for you in solving numerical problems. So please observe all these formulae carefully. Okay. So this is the expression for average power. and a few more concepts we need to discuss here. We need to discuss some cases related to this average power. So case 1, when the circuit is totally resistive, that means you have only resistor in the circuit. Okay, circuit is totally resistive. Resistive means what is the phase difference between current and voltage here? When the circuit is totally resistive means you have only resistance here in the AC circuit, then what is the phase difference between current and voltage in this case? Can anyone tell me? Yes, students? Can anyone tell me what is the phase difference between current and voltage in a purely resistive circuit? That means in the circuit you have only resistor alone. What is the phase difference? Phase difference is actually phi is equal to 0. Okay, we have already discussed that. You shouldn't have any hesitation to tell the answer, but I don't know why you are not thorough with this. So now average value of power is ERMS into IRMS into cos 0 degree. So this will give you 1. So IRMS into ERMS. That is the average value of power when the circuit is totally resistive. So case 2 now. What is the case 2 here? When your circuit is purely inductive or capacitive. When the circuit is totally or pure inductive or capacitive value. Purely inductive or capacitive. Now tell me, students, what is the value of phi? When the circuit is purely inductive or capacitive, what is the value of phi? What is the value of phi? When the circuit is purely inductive or capacitive, it should be plus or minus pi by 2, right? So that means your average value of power is equal to 0 because cos pi, when you put pi by 2, cos 90 degree, that will be 0. So instantaneous value of power will be 0. Okay. So here you see, when you have a totally resistive circuit, you will be having maximum power here. Okay. Maximum power dissipation is in pure resistive circuit. So that's the thing which you need to understand. So maximum power dissipation is in purely resistive circuit. Purely resistive circuit. And we are done with the power, and then we will be having the concept of apparent power. Now, what is meant by apparent power? The product of apparent voltage and apparent current in an electrical circuit, that is called apparent power. Okay. The product of apparent voltage and apparent current. This is called apparent power. So apparent power is given by IRMS into ERMS and of course we know very well IRMS is nothing but I naught by square root of 2. ERMS is nothing but E naught by square root of 2. So this will be E naught I naught by 2. Okay, the apparent power. So the next concept which we are going to discuss now is power factor. Okay, power factor PF. What is mean by power factor? So power factor PF is actually the ratio of average power to apparent power. So average power to apparent power ratio. This is actually the expression for power factor. Okay. So what is average power? That is ERMS, IRMS into cos phi. So ERMS, IRMS into cos phi is the expression for average power. Apparent power is ERMS into IRMS. So the ratio will give you cos phi eventually. Power factor is equal to cos phi. Okay. And in order to explain the power factor, we need to draw this diagram now. So here we need to draw this diagram. So here you see so here you are having Z and here you are having phi and here you are having XL minus X. So this is R. This is a diagram. And from this diagram, R is equal to modulus of Z into cos phi. So that means cos phi is equal to R by modulus Z. So cos phi is nothing but power factor. Okay. So power factor is equal to R by mod Z is the equation or concept. Okay. So this power factor actually depends. Okay, this power factor actually depends on different parameters or the different components. power factor depends on the components of circuit. What are the components you have? That is, if the circuit is purely resistive or inductive, like that. Okay. So like that, the power factor varies. So if it is purely resistive circuit, it means cos phi equal to 0. Sorry, cos phi equal to 1, because phi equal to 0. So power factor is equal to, this is not 0, actually this is 1. Cos phi equal to 1. So power factor is equal to 1. Okay. So when it is purely inductive or capacitive circuit, purely inductive or capacitive circuit, in that case, your phi will be plus or minus pi by 2. So what will happen to power factor? Power factor equal to cos phi equal to 0. Your power factor will be 0. Okay. So now from this you can understand that power factor depends on the value of pi. So the value of power factor can lie between 0 and 1, right? So the value of power factor lies between 0 and 1 usually. Okay. And it is a dimensionless quantity because it is mere a number. Okay. In case of resonance, your power factor will be 1. Okay. Because in case of resonance, your XL and XC will be cancelled. So power factor will be 1. And at resonance, your power factor is maximum. Okay. At resonance, your power factor is maximum. Okay. Right. And the P average. Here, what will be the value of P average? So P average is equal to VRMS into IRMS. Okay. Do you all understand the concept of this power factor, students? Do you all understand the concept of this power factor? Any doubt or
Yes,
difficulty
sir.
you are having? Any doubt or difficulty, students, you are having with respect to this power factor?
No, sir. No, sir.